So today we're going to do a sixth grade review. Now the sixth grade review is going to cover all of those concepts in geology that you've previously learned, but yet apply to what we're talking about in eighth grade. So the first thing we want to look at is the identification of the tectonic plates. So remember that the Earth is broken into plates, and it's not the whole Earth, it's the lithosphere. Remembering that the lithosphere is the upper layer, which is the crust, and just the tip top of the mantle. Now these plates are in motion relative to each other. So if we look at this map, the plates are mostly named for the continent or the landmass that is part of the plate. Some of them have other names like the Nazca plate, which is purely oceanic crust. So you do have to be able to identify these 8 major plates based on their location. So you need to know the North American, Eurasian, Indo-Australian, Antarctic, South American, and the African, Pacific, and Nazca plates. You need to differentiate between the lithosphere's crust because there are 2 types of crust. The continental crust, which makes up the land masses, is going to be thicker crust, but it is less dense, meaning it's going to break up a little bit easier, which is how we can make those mountains. It is made of granite mostly. Obviously there's other types of rocks, but it's mostly made of granite. On the other hand, your oceanic crust, which would be making up things like your Pacific plate, your Nazca plate, is a much thinner layer of crust, but it is very dense. It's very tightly packed because it's made of basalt, which is a volcanic rock, which is very dense. Now the lithosphere, like I said, is the crust and just the very top of the mantle together. That's what makes up the tectonic plates. The lithosphere is sitting directly above the asthenosphere, which is where we get that soft rock that can flow, has what we call the property of plasticity. And this is where our convection takes place. So when we talk about convection, remember convection is a form of heat transfer. Now this heat transfer takes place in liquids and gases. So in order for there to be heat transfer, there must be a source of energy. So let's talk about a lava lamp. So we know at the base of the lava lamp, there's going to be a light bulb. That light bulb is going to be our source of energy. It's actually going to generate energy and transfer energy through the form of radiation. It's going to heat the bottom of the glass. Well, the wax or paraffin that is sitting on the bottom begins to melt. It's becoming more loose because when particles are heated, they become less dense, which allows them to flow. In this case, when they become less dense, they rise to the top. Now, when you're at the top, you're farther from the heat source. So instead of gaining energy, you're going to transfer your energy to the surrounding material. So now the paraffin wax is giving off its energy and it's going to cool off and become more dense. And it's going to start to fall back down because when it's more dense, it sinks. Less dense particles rise, more dense particles sink. Now our particles are back near that light source, right, which is our energy. It's going to melt again, become less dense, and rise up. And it continues this process over and over as long as there is a heat source. If I were to turn the lava lamp off, eventually all the particles would settle back to the bottom. This movement, based on temperature changes and density changes, is what we call the convection current. Now, how does that apply to the Earth? Well, inside the Earth, remember, we have our core. The inner core is the hottest part, and this is where the energy comes from. So the inner core heats the material above it, in this case in the asthenosphere. It heats it so much in the asthenosphere that it becomes very soft, and you'll have pockets of magma as well. When it's heated, it's less dense, and it's going to rise up. It comes in contact with that cooler lithosphere, transfers its energy, becomes more dense, and sinks back down. Once it sinks back down, it's closer to the core, it heats up again, starts to rise because it's less dense, gives off its energy, cools off, becomes more dense, and sinks. So this continuous cycle happens over and over again, as long as the core is hot. So let's talk about these density calculations. So remember in 6th grade, you had to calculate density. We called it the heart formula because it's mass divided by volume. The M looks like the top of the heart, the V looks like the bottom of the heart. So it is a straightforward calculation. You need to know mass and you need to know volume. Mass is usually in grams. Volumes is usually in milliliters or cubic centimeters, depending upon if it's a solid substance or a liquid substance. So our unit for density is going to be two parts, like speed. You have to have a unit for mass and a unit for volume, so grams per milliliter or grams per cubic centimeter. It just depends. All right, so if we look, we're going to do a straightforward calculation here. But let's take a look at the second one. Now, in the second one, we have to first solve for volume. So again, flashback to 6th grade. So for volume, you have a graduated cylinder with water in it. The water has a volume of 50 milliliters. When you put your object in this case the green jade sample, the water level rises to 60.5. So in the second graduated cylinder, the volume of the water and the jade is 60.5. If I want to find the volume of just the jade, I have to subtract out the volume of the water. So 60.5 minus 50 to get my volume. Once you have your volume, you have your mass, and you can solve for density. So these are some of the concepts that you need to know from 6th grade, and they will all be on our test on Friday.